Okay, so there's going to be three kinds of things that we're working with this semester. One thing is called a scalar, vectors, and matrices. Matrices we're going to talk about next week. Scalars are just plain old numbers. So like -3 and 12.2 and so on. Vectors are, well, they're arrows. And I want to talk about those to start with. So what does a vector actually look like? So when I say it's an arrow, I literally mean that. So like this is an arrow, this is an arrow, this is a long arrow. And there are a few properties of arrows that can serve to completely describe a vector. So here are some of them. One is the length of the arrow, right? Like this one is short and this one is long. Another property is the direction. So like this one is pointed up and to the right. This one is pointed straight down. And then when we're living in the landscape, mathematical landscape of the Cartesian plane, we can talk about where the arrow starts and give that with coordinates and where the arrow ends. Well, some of these have special names. The length is called the magnitude. The direction is usually described by the angle measured from the positive x-axis. And the starting point of the vector, this is called the initial point, and the end point of the vector is called the terminal point. So maybe let's see a picture on the Cartesian plane. Okay, so here's a nice little vector on the Cartesian plane. So we can see that this has some length, and it's got an angle that we could measure from the positive x-axis. We'd have to measure that angle by drawing a parallel to the x-axis so that we could measure that angle. And it's got a magnitude, the initial point and the terminal point, and this over here is the initial point. Now, all right, so now we've got some of our jargon established. Let's talk about some different types of vectors. So vectors can live like this out in the middle of the Cartesian plane, just pointing willy-nilly wherever they want to. But there's a special kind of vector called a position vector. And the idea with these is that you think of them as pointing at some position in the Cartesian plane. So like that means that we're going to start at the origin and have a vector that points at some point in space, right? So position vectors are vectors with an initial point of 0, 0, and then they're pointing at something else. And position vectors, so let's see, let me label some things on this axis. Let's say this is -2 and here's 4. Position vectors, let me give this one a name too. So I'm going to call it V. And usually the little arrow over a lowercase letter is the notation that we use when we're giving a vector a name. In the text and in typewritten stuff, it's usually no little arrow and it's just a bolded variable letter. But when you handwrite it, it's usually with a little arrow. And the way that we denote a position vector is really literally just by giving the coordinates of the point that it's pointed to, but we write it in square brackets and don't use a comma. Right, so this is the vector pointing from the origin to the point -2, 4. Okay, so there's different ways to describe a vector. One of them is to say, okay, we're going to start at 0, 0 and point to -2, 4. And when we think about what that really means, it's sort of like giving directions to that point, right? It says when we see -2, we know we mean go left to -2 units on the x-axis, and then go, when it says 4, right, in the y component, we know that it means go up 4. But another way of describing the vector is by just saying something about a direction. So go in this direction and then go this far, right? In other words, we're giving a magnitude and an angle. So the magnitude tells us the distance that we need to travel, and the theta gives us the direction that we need to go in. So a useful thing to be able to do is to compute back and forth between these coordinates for the point that tells you where where the arrow is pointing to, and these other kinds of directions where we have the direction and the magnitude that tells us where to go. All right, so let's take another example of a vector. So this is about now computing the direction and magnitude. And it's pretty easy. It's just a little bit of a reminder about trigonometry. So let's say we have a vector v that's pointing, I don't know what, 5, 3. So in other words, this is our vector. If we want to compute the length of the vector, we can do that by using the Pythagorean theorem. So I'm going to just kind of draw the triangle that is suggested by this picture right here. So what we're looking at is really a triangle with one leg, a right triangle, with one leg length 5 and the other leg is length 3. And so this length, right, that's our arrow. We want to compute the length of this arrow. The magnitude of a vector is usually denoted with a kind of a double absolute value sign. And so to compute that magnitude, right, all we really need to do is use Pythagorean theorem. And so this tells us that the length of this vector is the square root of 3 squared plus 5 squared. So that's 9 plus 25, square root of 34. To get that angle theta, it's again a little application of trigonometry. So I can see it by remembering that, let's see, we know the lengths of the little legs here. So I can use this fact that the tangent of an angle is equal to the ratio of the length of the opposite side to the length of the adjacent side. So that means the tangent of this angle is 3/5. And if I know that, then I can compute the angle itself, right? I can use an inverse trigonometric formula to do that. 0.54 radians, which about 31 degrees. I wrote this at the top of the first section of the textbook, but I'll write it here again too. To get from radians to degrees, you have to multiply by 57.29. All right, so I think that's where we can stop for this first section. What we have done now is learned what vectors and scalars are, and we've talked about some of their properties and seen how to compute a couple of those properties when we're given the coordinates of a position vector.